This interview with Fred Link in Tampa, Florida, was 1 year later at the 37th Vehicular Technology Conference.
Good afternoon.
IEEE Vehicular Technology Conference, 37th conference being held in Tampa, Florida. And the occasion for this little taping session is to interview Mr. Fred Link, Life Fellow of the IEEE and member of the Board of Governors of the Vehicular Technology Society. I'm Sam McConoughey, also a board member.
And as president of the Vehicular Technology Society. Now go on, Sam.
He just doesn't follow the script at all. Ted Stoner, who's the Vehicular Technology Society Nobel Fellowship awardee for this year.
1987.
1987.
And we're very proud of it.
We are. Ted?
We're very proud of it.
And you're going to be taking your master's degree at
University of Purdue.
Purdue
You need too much.
in electrical engineering, correct?
Correct.
And specializing in mobile communications.
Yeah, mobile communications, digital signal processing, those areas.
Good fun. And then our guest of honor, Mr. Fred Link. And Don Bishop, editorial director of Mobile Radio Technology.
A renowned Fred Link booster.
What's this?
Well, he needs a booster.
I'm a renowned Fred Link booster.
Oh, you are?
That's
He
right.
needs a booster at his age. He needs a jump start every morning. Well, anyway, the purpose of this meeting is to kind of explore with you, Fred, some of your history in radio communications. And I would like to start off with the first question that I've used when things get dull, is to go around and ask people, what was your very first experience in radio communication? And when was it?
This is one I can answer rather easily. And that would have to be in year 1918, when I was a Boy Scout and coincidentally became an early Eagle Scout, possibly the first one in Pennsylvania, I'm not sure. But in order to become an Eagle Scout, the merit badges at the time listed one qualification as I think they just simply call it wireless as a merit badge. And that became something. So in order to pass the merit badge, you had to do an International Morse code test of, I believe, 5 words a minute, or something like that. It may be less than that, but it wasn't too hard, too difficult. Having passed the merit badge test, and now I had a code capability, I wanted to find some use for it. And there wasn't any use for it because now the war had started. The World War I was already on and going along. But I found that the railroads needed telegraphers because the good telegraphers of the time had all joined the service. And the people they had manning the towers in the railroads were, for the most part, retreads who had come back out of retirement to handle this operation, or anybody that they could find. So, as a Boy Scout situation, the thing was, I volunteered to be a standby telegrapher at a watchtower on the railroad that went through York, Pennsylvania.
Well, Fred, hadn't you learned the wrong code? Didn't you learn International Morse instead of
Yes, that's
Continental
why you
Morse?
get around to that. And so consequently, the clapper type of Morse code is obviously not the same thing. And it didn't take the people on the railroad telegrapher circuit long to realize they had a greenie at the other end. And so they would really give it to me in no uncertain terms. And so by necessity, I learned the other code.
As an aside, for those who might be watching, the landline Morse code is quite substantially different than the
It is
international Morse
less
code. Obviously, you use a sounder, as Fred called it, a clapper. But, for example, the letter P in international Morse is a string of 5 dots, where in radio or international code, it's a dot,
Dash, dash, dot.
So it would be easy for an old telegrapher to know he had a radio man at the other end because he wasn't sending the right code.
How could you keep them separate in your mind?
You do that, I'll tell you what. This is something that people have asked before. How do you do this? I have seen telegraphers that are familiar in both international and continental Morse that could do this instinctively. They'd look at one person, they could talk international Morse, they'd get on another circuit and talk to you and talk with a clapper, just as easy as not. And this is something I found that the human mind can put up with, because I had a grandson who was born in Mexico, brought up in the background of Spanish, and yet when he was about 4 years old and he was in the company of American visitors and so forth, he'd instinctively talk in English. He'd turn right around and talk to the maid in Acapulco in the setup and talk Spanish. He'd turn back to the other one and talk Spanish. Well, the same thing goes in this code business. You get instinctively to separate it. I don't know why, but you do it.
Well, I wonder if one of the differences might have been, because I'm not familiar with how the railroad telegraphy was set up, that would it be called American Morse?
What, the continental Morse.
Continental Morse.
Yeah.
Was that done with a clicking, whereas international Morse you'd be expecting either a hissing sound or a tone?
This is entirely different. In other words, the clapper, I call them the clapper because that's what the telegraphers call them.
Sure.
They didn't call them anything else. And it's very, very difficult to follow, especially when you start out. But if it's by necessity, you're going to learn it, or else look like a jerk in the minds of your peers that you're dealing with. You learn it. You learn how to do it. So it took a week's time.
Did you get fired by the railroads then? Or?
No. They were very happy to have anyone that could even, that was warm. I mean,
You must have been, what, 14 then?
Oh, well, let's see. Yes, I was 13 to 14. Yeah, I was born in 1904, so it would be 14. And I know in carrying this out that very quickly I learned how to put up with this situation. And that is when someone would send a message, I just came back with an R and said that I understood it. Well, I didn't. And then I'd write on the chart the certain station that called in and this message, you better call back and find out what it is.
Do you remember how you sent an R?
I remember exactly. I sent an R to David, and that's all I did. And they either thought at the other end that the real smart one who knew all the answers, don't test him too far or her too far, or they decided I was being hoped. But in any case, I got away with it. But they were so happy to have anyone who would come and spell them for half an hour so they could have lunch. And that's all. And all I did was just simply stand by. And when a person came on the circuit with an important message, I let them know that I couldn't handle it. And that they better check this back. But after doing this for 6 months or so, you learned it. I mean, just like you learn everything else. So now, he said, the question was initially, I'm way off the question, but the question was how did I get into radio? Now I had this capability of code transmission, and you instinctively want to find some use for it. You want to do something with it. Well, then you do, because during the wartime there weren't any amateur stations permitted in operation or anything like that. But about this time, the war was winding down, and people were being mustered out of the service, and the assistant Boy Scout master was a chap who had been a radio operator on a ship at sea, a merchant ship. Well, he liberated some equipment from the ship. And since our Boy Scout troop was located in the YMCA at York, Pennsylvania, we decided we'd get into an amateur station. Now, they were going to permit amateur stations to go back into service. And we were issued a license in the name of the YMCA, 3OV, an initial two-letter call, 3OV, for this station. And we utilized an unsynchronous spark transmitter with a 1.25 kilowatt Thordarson transformer for power and our own photographic plate condenser setup. Two things are important about this amateur radio station. One was none of us had the faintest idea how to tune an antenna. None of us cared whether we tuned an antenna. No one in the world had any idea of what frequency we were operating on. No one was listening to us, so it didn't make any difference. So, I mean, the thing is, this station worked very effectively across the street. I mean, because you could see the flash of the non-synchronous rotary spark gap and the noise that went with it and the ozone and everything else in the air. I liked it. I liked it tremendously. And very honestly, I don't have any record that ever transmitted more than about 25 miles that anyone heard me.
Explain what you mean by non-synchronous rotary gap.
Well, a non-synchronous rotary gap was simply a 1750 RPM motor driving a notched wheel, which was an aluminum notch wheel, that as it started up, it went up, and the tone of your signal was synonymous with the speed of your motor. I mean, as the motor went up, the tone went up, and so forth. And until you got near synchronization, of course, if you had a synchronous motor running the thing, it ultimately got up to 1800 or 3600 RPM, and that was it, and you had that. But we weren't that lucky. We had a non-synchronous motor off a sewing machine or something like that. I don't remember what it was.
How did you key this telegraph transmitter?
Well, you keyed the primary power in those days. I mean,
primary to the
you keyed the primary power to the transformer. That's correct.
And the gap was in the secondary.
The what?
The rotary gap.
Oh, the gap was in the output circuit of the where you fed the high power, the high voltage from your condenser bank into this rotary gap situation, and that was supposed to be tuned with a helix and so forth to get roughly a frequency where you wanted. Well, of course, the amateur frequencies you're permitted to use were to be somewhere between 360 meters and 200 meters. Now, 360 meters and 200 meters is not very high frequency, and on this situation. So I suspect that our station there was closer to 700 kilocycles than it was to 200 meters. I mean, because that was a nice frequency to be near. I mean, there wasn't anything else on it. You had maybe one or two broadcasting stations and all.
This is what, about 1920?
This was 1918 to 1919.
Okay.
About that.
And you said you made your capacitors out of what, glass?
So yes, some glass photographic plates.
What, tin foil?
Tin foil. I mean, well, aluminum foil. I mean, whatever it was. And I mentioned I had to eat a lot of Hershey bars because that's where the stuff came from. And so, why did I get into this? Well, I got into it because of the fact that I was interested in this to become an Eagle Scout, and that's what got me to learn the code. And learning the code, I now practice the code in the railroad as an unpaid volunteer at lunchtimes and so forth. But I'm interested in this business, this amateur, this radio business looked like something to be very interested in. So we had the station, we got the license, we went on the air, and we talked to people maybe in York, maybe there were one or two other amateurs in York, Pennsylvania at that time. And as I say, I don't think very honestly that anyone over 25 miles away ever heard the station. But that didn't make any difference because you had the fun with it. and working it out. But about that time, you also heard some signals with your very ineffective, although if in my case it was extremely effective because I liberated from the telephone company some VT2. Now Sam knows what a VT2 is. I don't think you know what a VT2 is.
I don't know what a VT2 is.
Well, a VT2 is a 205 tube that was made by Western Electric for repeater service. And it, in other words,
that really doesn't tell me too much.
Western Electric at this
VT
particular...
stands for vacuum tube 2 is the second model.
Okay.
And that's right. Well, no, not
What's
quite. No, the
repeater
VT1 was a simple oscillator tube. I mean, a simple triode. But a VT2 was a power tube. A VT1 was a low energy type of tube. So it was amazing that the telephone company in West Electric, this is something that made me very conscious in the beginning. That I was a backer of the Bell system and the Western Electric and Bell Laboratories and the people who put this stuff together. Because these tubes, which I later started to realize the value of them, because as I went into business in radio as a business, I was with DeForest in the tube department. I had charge of the tube department. So I became very conscious of the tubes later on. But in these early days, I was very surprised that these VT tubes, what are now being discarded by the telephone company after some 10 years in service in repeaters under the water in other places. They were terrific tubes. I mean, they were much better than anyone was designing at the time. And Western Electric had designed these tubes maybe 15 years before this. I mean, did a tremendous job.
These vacuum tubes that he's talking about were about the size of a Florida orange.
Okay.
Spherical,
round
clear
tube.
glass, with a little vacuum nipple at the top, a brass base with 4 short pins.
That's correct.
And the plates were not boxed but flat and with a V filament in, so they cast a very nice warm glow when you lift them up.
I can picture the style of tube.
Well, I mean, to tell you what,
that means
I
that
wish
they were
I would
amplifying-
have kept some of these tubes because they're reflectors in them now. I mean,
Does that mean that they were amplifying audio signals over the phone lines? Is that what they-
yes, that's right. That's where they're amplifying audio signals. That's exactly what they were made for. And but now
They would oscillate to a
when their emissions started to drop off to a point where they weren't considered stable for repeaters. Now you have to keep in mind that these repeaters are put into locations. The telephone company did at that time. Put them into locations where they didn't expect to look at them for 5 years. So their maintenance requirements were such that even in this day and age, they would think it's impossible to say, look, I want something that's going to operate for 100,000 hours and so forth and never give us any trouble. But if it didn't do that, it wasn't any good to them. Because this stuff would be planted underground where they don't want to have to dig up the streets all the time to get the stuff. So, in any case, about that time, I was using these tubes, the VT1 version, for a receiver, which is a detector and one stage of amplification. No RF stages, just a detector and one stage of audio amplification at that particular time. And so I was hearing signals that other people weren't hearing. By then I was hearing CW signals. And this was just the beginning of the CW era, about that time. And I decided this spark transmitter is great, but I wanted to talk to somebody.
Great for watching.
So I went to the local
anybody.
telephone company, which headquarters was just across the street from where my home was, and I said, there must be some of these VT2s around somewhere that